Welcome to the Helix webinar series. Today's session is on BMC Helix Operations Management, Make Your Events Matter. Joining me today is Bjorn Heide, our Principal Solutions Engineer, who's going to walk through the topics and provide a demo today. We also have joining us John Macy and Steve Mundy in the Q&A. So what we will ask is, if you're not really aware of where you can put your questions, there is the Q&A section of Zoom. You will find that at the bottom of your screen. Any questions that you have during the demo and the slides, please put them in there. Our team will do the best to answer them. And then we will have roughly 10 to 15 minutes at the end where we will take some to the live Q&A. Until that time, you will remain muted so we can get through the content today. So I'm now going to hand over to Bjorn to get us started and give his formal introduction and go through the agenda. So over to you, Bjorn.
Thank you, Samantha. Hi, Bjorn here. A little bit background about me before we get starting with event management. I live in Stockholm, been at BMC for about 25 years, went through almost every monitoring event management product BMC have, and now, of course, the latest and greatest BMC Helix Operations Management. We have a full agenda for today that I have prepared, and looking at the participants, I can see some well-known names within event management. So happy to have you all here listening into event management on afternoon in EMEA at least, and if there are any US people joining in the morning for you guys. What a way to start a morning with event management. So let's look at the agenda. Before get started, I will also mention that I'm lucky enough to have both Jonathan and Steve from our support team to help me manage and moderate the chat. So please add any tricky questions you have on the chat, and they are happy to respond on that. So this is the agenda for today. It's brand build material for this webinar. So hopefully we will be able to keep our time in around an hour. You know how it is with event management. There's a lot of details. There's a lot of things to discuss. What I have prepared is a little bit introduction, why bother about event management at all. Some basics and the platform we have now with Helix Operations Management. Some overview of the event console, the console used for the operators, and some important things we cannot miss when it comes to event management. That is to manage blackouts. It's always a challenge within some organizations. How to set the correct assignment group from event to ticketing, and after that, going through some slides, perhaps some discussions with you guys. I'm happy to have that. I'm going into building some event policies and actually doing this live from start. And of course, we live in the times of agentic AI, AIOps, GPT, and all that kind of good stuff. So of course, I will connect event management to Helix AIOps and generative AI. So I'm not missing that at all. Okay, if you guys are ready, I'm ready. Let's go. So just to set the scene a little bit, event management been around, for years and years, decades and decades, right? And many of the participants on this call perhaps work with event management on a daily basis. I did list here some of the top challenges that we still struggle with within the event management space. That could be event overload. It could be lack of event context. Could be still some manual event handling. I see that still at some organizations on different ways. It could be a challenge not to have everything integrated from the IT environment. And if it's not integrated, all different event sources, we lose part of the visibility as well. So also, of course, today, everyone is an AIOps expert, machine learning expert. What about the expertise and the people actually working on configure event management? So you guys are still there, I know it. So, but there can be organizations that struggle with expertise and resources as well to make sure that the event management space is properly configured. Event documentation, that would be for the operators. Do they have enough documentation to act on the alert coming in? Where is that documentation stored? How do you put that into action, basically? Could be knowledge articles as such. So that's some area that some customers have solved very nicely, but some are still struggling as well. So this is some of the challenges we still see. And to put event management in the context of the Helix platform. So event management is a key part of the whole ITOM platform. So we have divided the platform into 6 different pillars, as you can see: ingest, discover, monitor, optimize, automate, and remediate. And each pillar have their key capabilities, as you can see within ingest. We have the native ingestion using the BMC own endpoints. We do have open integrations with the intelligent integration framework. If we move into discovery, this is a very central piece nowadays within the Helix platform that is shared between ITOM and ITSM. That is to have an updated map of your IT infrastructure, applications, and services, how that is consumed. So if we jump over a little bit the monitoring pillar and see at the end, we have the whole power of AIOps, machine learning, and generative AI happening, basically. So this is using the AIOps power is using what is coming in on the pillars before. That means there's still a little bit crap in, crap out, basically. And this is where event management comes in very nicely. It is positioned in the middle of the platform, as you can see, event management and enrichment. It touches some of the key capabilities in the platform, like ingestion, to ingest the event, using BMC's open framework to integrate the most popular applications and tools in the market to get all the alerts floating into the system. What happens then, if we focus a little bit on event management and enrichment, we do support the AIOps. So the AIOps will perform much better with a proper event management platform. And that would be creating the machine learning situations automatically. That's a correlation to within the topology to find and isolate the root cause. Of course, we are then into noise reduction, not creating too much tickets, be able to run the different automation tasks with intelligent automation framework. And also quite lately, we have the best action recommendations that are based on Helix GPT that will very, very nicely take all the events, the messages within all the events, and make sense of it and recommend an action to resolve. All this, how event management support the different outcomes in the Helix platform, we can see them listed here as well. Okay. So let me go into top things done within event management. So what do you do if you work with event management? Yes, you configure event sources. So that could be everything from a tool sending their alerts into the event management platform, or configure an out-of-the-box integration with access and keys and everything. Doing that is improving the visibility, right? One of the challenges. What else do? We do filter and normalize the events, and that is coming out to the reduction of incidents. We do enrichment of the events, could be with external data source, and that will help us put context to the events and be able to prioritize them much better. Could be a service context, could be location, could be who's the owner of the CI or something else. It's very, very common that we add different correlation policies or actually let the AIOps machine learning take care of correlation together with the topology, and that will reduce further the incidents, blackout, and maintenance. This is a dear topic within event management. So if we don't do this, we are actually getting the false positive incidents during maintenance. So this is an important area that I will touch a little bit on. Setting the correct assignment group for incident. If we are able to pinpoint the resolver team directly from the alert to the incident resolver team, we are then able to speed up the resolution time instead of just sending everything to the service desk that then act, as a bridge to reassign to another support group. So that's one important area as well within event management. And of course, automate different parts of the event processing all the way until notifications and of course automatically create incidents. There are a lot of dashboards and KPIs to follow up within the space, how to improve event management, how to reduce the noise events, how to cover more of the monitoring so we get more alerts. All that is done with the help of KPIs and different dashboards that pinpoint improvements areas as well. Let me then take us into the Helix platform. So I would think that many people on this call are familiar with a true site operation management or even some platforms before that, Patrol Enterprise Manager or BEM as well. So BMC have a long history of advanced event management, right? So a couple of years ago, I think it's now 4 or 5 years ago, we realized we need to build a new platform, and it needs to be based on the latest technology. It needs to be containerized so we can deploy it on different places, environments, needs to be able to deploy it on-prem, needs to be run in SaaS native or private cloud. So we make sure it was a containerized platform based on microservices, of course. So this is actually the platform for Helix and used by event management. There's a nice blog from BMC that talks a little bit about the microservices and the architecture that I can recommend. You will have that when we share the slides afterwards. So this is the platform itself. And if we then look at event management running on this platform, so what we have done here, for processing of the event, so there's an incoming event, it needs to be processed through a number of event management policies. We picked Apache Kafka, so there's a number of Kafka topics actually that is in parallel processing your events. This is a key thing in the platform that allow us to scale, basically. So you on the call that work with BMC event management cells, you are very familiar with like a cell network that you spin up more cells. One cell is a single process. You can have multiple of those cells on the same host or spread it around with different hosts. You do that to scale, to divide the processing and everything. What we have now built in the Helix platform for event management is a number of partitions within Kafka topics, hundreds and hundreds of them that are taken in the events and basically doing parallel processing. You can think about it like hundreds and hundreds of event cells, basically. Okay. After we have processed the event, it's then indexed and stored in Elastic. And this is just beautiful. So Elastic will allow us to use huge volumes of events and query them in real time, could be with Helix dashboards or in the event console, and get the results and the event list in no time, basically, as a result. And the reason for that is that everything is indexed in Elastic. And as I mentioned here on the slide, out of the box, we do store the event up to 180 days, basically. So that's the default setting. And that's a quite good period of time to store the events. If you need longer storage, you can easily point the Helix platform to another external storage, basically, for long-term storage. But this is quite good for the operational needs and the Helix dashboarding. So that means the first 90 days, we look at the last modification time on the event. So if that is then over 90 days, we will actually put it to closed automatically. And a closed event will then be automatically purged out from the system after another 90 days. So that means if you have an event that is updated time from time, you're actually storing it longer and longer with the latest modification time. As I mentioned a little bit, we do have very nicely built-in Grafana. So Grafana is a very popular dashboarding analytic platform, as you know. There are many people in your organization that are probably used to build Grafana dashboards. BMC deliver a long list out of the box dashboard, so you can copy them, modify them to get started. One thing with the new platform that we did not have in TrueSight Operation Management was an extensive list of API endpoints. So because we started to build it, with the microservices architecture, each microservice is basically talking to each other on API. So you need to build the API gateways and everything. We took that principles and basically started to add endpoints to almost everything you can do in the interface. So you can build your event policies using endpoints instead of the GUI. You can create blackout policies with endpoints. You can do even event operations that would be close or update an event, just as an event operator would do in the console, right? This open up the possibility to automate fully around event management. So with the platform we looked at, a key part is that we are completely event-driven, the whole architecture. When the event is presented on the event console, it's already processed, it's already ready to be used. You have the results directly. It's gone through all the event processes, it went through the machine learning process, AIOps, all the capabilities, and presented to the end user. Instead of doing batch processing, we are event-driven. Let's now leave a little bit the platform and go into event management processing. Before that, is there any special questions happening on the chat around the Helix platform? John, Steve, are you?
Yeah, not so far, Bjorn. You're covering everything really nicely.
Good to hear, good to hear. So let's then dig into some event management details. This is an overview of the processing. So we are getting events into the platform on different ways, through the patrol agents, of course, through the event APIs, through different connectors or integrations that we have built. You can build your own connectors as well with developer tools that are using frameworks like FluentD. Many customers are using Logstash as well to just ingest the events and Logstash supports hundreds and hundreds of connectors. So it's very flexible to get in your alert, right? So it then go through the important steps like suppression that would filter out different noise, things that are not needed. We need to identify if the same event comes in several times. That's called deduplication. We need to identify that and make sure that we only proceed with one event instead of several events. And thinking about it, that's very important when you try to create a ticket as an example or do a notification. You don't really want to have that 100 times created. You just want one ticket created for one alert, and then that alert is updated basically. After suppression dedub, we go into the enrichment part, that is adding more context. We do support external data sources. We can do today enrichment directly from BMC Discovery. I will show that a little bit live. That's a cool, powerful feature as well to update the event with any discovery attribute basically. Correlation. This is an interesting area, of course, important area. We want to make sense of the events, correlate them into one main event before creating a ticket or notification. Today, of course, this is mainly driven with machine learning, AIOps. I will show that as well. But you do have the possibility to teach or build your own event correlation policies within Helix. So if you have identified a special situation, you can take that, configure it in Helix, and there you go. So we do combine manual event policy correlations together with machine learning and present them on the same page. Okay. Next, a little bit about the events. So we are discussing event management and hopefully everyone is still awake. So let's go. Events are classified. If you look internally in Helix for the event classification, it looks like this out of the box. BMC have provided a number of standard out of the box events, and the parent one, the read-only one, is just called event. That's the root. Underneath, there's a number of children. As you can see, there are some special one that BMC is managing for machine learning situation, prediction. When we get a log alert from the BMC log analytics could be. And then you have monitoring event. Under monitoring event, we want you to add all your own custom event classes. So you are very free to create your own subclasses underneath, as you can see down here, custom class 1 and 2, and your own event fields, or what we call them, event slots. Everything is in a parent-child hierarchy. That means everything you create down here is then getting all the attributes from monitoring event, all the slots, how it's all the attributes for that slot, and also up to the root event as well. So it's a combined. So why do you create different event classes? This has a little bit historical reasons. If you look at solutions like BMC Impact Manager and BMC Operation Management, it's a very effective way to treat the event processing, because you can easily say, I want to do something with all the OP5 events. I want to do something all with the Dynatrace events, or I want to do something with all events, right? So it's a very easy selection criteria, the event class. And also it's quite important for reporting and dashboarding. So you can easily say, hey, present all my Prometheus alerts, right? So it's an effective way to slice and dice your events. Next, there are things like event status model. So if you look at an event lifecycle, the first one is the automated. That's perhaps the most common one. An event comes in with the status open. It can then go into blackout if there's a maintenance period happen, then goes out from blackout to a reopen, and then finally go into closed. Normally, it's closed when the monitoring tool or the event tool sends an okay event or severity okay. That is many times then closing the event itself. So that's a typical life cycle for events. Then, if your organization have operators working with events, in the NOC, we do add things like acknowledge and assign. That means the operators works in a structured way with events, and they can set the status to acknowledge. That means I have seen this event. No one else needs to investigate it. It's known, but we wait a little bit on doing anything with the event. And then when they start to work, they put the event to assigned mode. That means basically we start to work on this event, this alert, there's a ticket related to it, and it goes into the resolver team to find the resolution. So that's the status model. If you think about the event status model, it needs to be mapped to the incident status model. It's quite easy. So whenever we create an incident, the open events are then an incident new, right? Whenever the event is closed on the event management platform, we automatically put the incident to resolved. If that's the configuration you have, it's this mapping is the out of the box. You can change it basically based on your own way of working. So basically you can say to the event management platform, when you configure the integration, you can say, well, if the event is closed, actually I want to update the incident notes instead of putting it to incident resolved status. So that's a configuration you can do. And the reason why we focus on blackout management in the platform is to avoid creating incidents during blackout status. Okay. So the main ITSM or ticketing system we integrate to is, of course, BMC ITSM, but also ServiceNow is a common one out there. So we do fully integrate to incident and change management, both for BMC Helix ITSM and ServiceNow ITSM as well. Once we have created tickets, we also would like them to be automatically assigned to the correct resolver team. This is a little bit technical flow. I apologize for that. Some on the audience perhaps like it, this level of technical details. So this is actually a step-by-step flow from the event. What happens in the Helix platform going through the discovery lookup, the Intel automation that is responsible for actually mapping and creating the tickets between event to the ticket and what's happening within ITSM. The reason why I detail at this level is to give you a good understanding how do you configure incident assignment to get it automatically to the correct resolver team. So if you start here and look at events that have no CIs, yes, they exist. There can be alerts without any CI associated. The possibilities you have is to start setting the assignment group or support group directly on the event that is supported. That's what I call out as event enrichment. It is still quite common out there that I see big enrichment tables just for assignment. If that assignment is not set, you can then fall back on the ITSM foundation data that is the classic organization location and categories, basically, in the assignment engine. So that works fine. Of course, you would set a default assignment group if that would be a service desk as well, if no other group is populated to the event. If we have a CI, now it becomes a little bit more interesting. If we have a CI associated with the event, and this has happened automatically on the DSM lookup nowadays, we try to find the correct node for the event, associate it, and update the event with some node details. You have much more possibilities for assignment. Still, you can set it using your lookup tables. That would then, be an exception to the other routing orders. But the interesting thing here is that you're able to use the CI settings to do the assignment. So we do support the CI settings supported by managed by location. And if you have a CI and a service associated, if you have the event is having a service context, then you can also use the service CI categories as well for assignment. So this open up to quite good automation, and open up for you to start migrating your own lookup tables into the CMDB CI settings, basically. Okay. I will leave incident assignment a little bit and go into another topic that is close to us within event management. That is, how do we handle blackouts? So blackout is during a maintenance of typically a node. It needs to be patched, rebooted perhaps. We don't really want to have the monitoring sending in alerts that become tickets. We want to suppress that, right? This is all about blackout management. We do it in Helix ITOM in 3 different ways. First of all, we have a change management integration, both to, of course, BMC Helix ITSM and ServiceNow. So if you activate the change integration, you will actually get a change policy automatically created in Helix Event Management for every CI that is under maintenance, is scheduled to be under maintenance. And that policy will be updated when the change is going through the different statuses. So that's a quite fantastic way to do automated blackout management and suppress the tickets. We also, of course, support you to go into the event management platform or BHOM and create your own blackout policies. Could be scheduled one, could be a one-timer. It's quite built out and a flexible way of doing it. And you can decide the behavior for the event after the blackout has ended. Should you keep the event in blackout status, or should you reopen the event if it's not closed? Endpoints. So you can see the complete list of blackout endpoints. There are endpoints to create your blackout policies, to delete them, to update them, to search and see and get the details around blackout policies. There's a full set of endpoints that allow you to automate blackout maintenance. And how is this used? This is one example. So assume in your organization, you have an automation tool that will patch the servers, right? So in the beginning of the patching for each of the single server, you can actually send a signal to or API and call to Helix and say, hey, this server is now starting its maintenance period. Here's the timing. You can predefine a start end time, or you can let the automation tool, once it's done with its patching or its automation task, you can send a stop time basically for the automation policy. So this is quite flexible and popular way to do it, as you can see. And the The JSON body is quite easy to use. It just contains some name descriptions that are needed, and then the event selection criteria that would be host name equals the one that should be under maintenance, and then the start and end time. Okay, let's look at the event console. So the event console is a tool for the operators that will display the complete list of events. There are capabilities like sorting, filtering, present your events in the way you want. I will go through and show you live a little bit later when we go into the demo scenario as well. So, continue. Time is flying, I can see. I will speed up a little bit. Event policies. So the event policies are a guided way of creating basically event processing. You add the standard information like name and description, what are the precedence order for run it, the event selection criteria, to what event does this policy apply, should it be active all the time or active during a special time frame, scheduled one, and the thing you want to do with the events that are selected. Could be suppressed, it could be enrichment, could be a notification. So that's the general structure. With that, I will actually speed up a little bit and go into the demo. Okay. So I have prepared a nice little demo for you. I will quickly explain the setup. I have two Helix tenants, one that have event only, as you can see. There's no AIOps, none of these features are enabled. The other one have, of course, event management. That's an integrated part of the Helix platform, but also AIOps and Helix GPT enabled. So what we will do in this little scenario and demonstration is ingest, using the Postman client, ingest noise events, critical events, warning events, to both the Helix tenant with events only and to the Helix tenant with AIOps enabled and Helix GPT. And those will be sent, of course, to the same set of nodes. There are 3 different nodes that I will use that are listed here. There's a load balancer member, there's a load balancer service as well that are getting hit with some noise and some critical alerts. And based on that, we will create incidents automatically, of course, in Helix ITSM. So they are configured exactly the same. The only difference here is what I have enabled on the AIOps side. Okay, so I will start with step 1, ingest raw events. Then we will move on and build some event policies and ingest again to see the results. And then actually we'll show you how it all looks with the latest and greatest within generative AI with events. Okay. Let's go into the demonstration. So this is the Helix portal. I will quickly check that the AIOps is disabled. I go into the features within AIOps, the configuration page, look at the product features, is disabled. So in this case, I will ingest raw events, and there's no help from AIOps at all. The event list is empty. The only enabled policy here is actually to automatically create an incident, nothing else. Okay. So using Postman client, I have a large collection of endpoints, as you can see, on different areas within event management and metrics. If you want to have this, just reach out to me. I'm happy to share the Postman collection if you're using Postman. So I have divided one collection for the event-only Helix tenant and one collection for the AIOps. But it's exactly the same events that we're ingesting. I'm using the endpoint events to ingest. That's very common usage. And I'm sure that a lot of people in the audience have used this endpoint themselves. As you can see, there's a number of events that are sent in, right? There are noise, there are alerts, there are warnings to the different nodes. Let's send it in. 1 time, 2, 3. Let's do 4 times. The events are coming in, as we can see. The incidents are created, right? So this is the step 1, the raw events. There's no event policies happen. There's no, event rules at all on this. Just go through the system, create the incidents. We have a number of problems with this. One is that, there's a lot of noise that we want to get rid of. That is cluttering the console. If the noise would reach severity critical, that would be an incident. We don't want that. And if you look at the different events for a single node, you can see it seems to be repeated, the same event happening. Let's see if we look at this, and I'm getting a new incident for each, right? Bad behavior. And there's no special context. There's no information on this event from discovery. So let's fix that. So I will go in and build a couple of policies and checking the time. So let's build a suppression policy. Suppress events. You need to tell for what events does this policy apply to. So that's the event selection criteria. In this case, I want to have monitor event. Remember the event class we looked at, and I want to suppress the noise. And I will use the message. You can see all the functions, easy to use, easy to build, no more MRL rules and everything. It's totally GUI based. So I will pick the noise message here. Let's do it. Speed up a little bit. I take in the beginning. This is a keyword for the noise. In a real life, this selection criteria is perhaps a little bit more detailed, of course, but for the demonstration, we go ahead with the message. And there's a selection, what do you want to do with the events? In this case, I want to suppress them. If there's a matching on this selection criteria, just press it. That means drop from the engine. Don't save it in Elasticsearch. Save. Enable, one policy, easy. The next thing we want to fix is dub detection. There's same events coming in, right? Dub detect. So once more, I have the event selection criteria. I do, let's see, equals class, monitor. In this case, I want to do dub detection on all events coming in from the class monitoring events. That will take care of most of it. I do add advanced enrichment that open up the panel to build my flow, to build my event process. There's a lot of capabilities here available for you to basically build everything you can think about around event processing. In this case, I will do a dub detection. That's a lookup if this new event has a matching old event that is still active. Okay. I go into the lookup and you can see you get some help from the system to say, here's your incoming event. What do you want to do? A lookup. And in this case, I want to build a custom criteria to say, look up if it's the same host. and object as well equals the same object and the same metric. If it's the same host, the same object, the same metric, we consider it to be the same event, basically. You see how easy it is to navigate and build. I actually just want to search on the last occurred event, not all events. Apply. When this happened, when I have a match, what do I want to do? I want to update the original event, the one that exists, that probably have already a ticket created. So that's the one I want to update with new event details. So I go into update and say, let's enrich the original event, update severity. Then let's do severity, the old severity with the new severity. Apply. And you can continue to update any slots you want on the event, but in this case, we just update the severity and then drop the new incoming event. We don't need it anymore. We don't want it. So just use a function called drop new event. Apply. Okay. Dub detect. Enable. We will also do topology enrichment to give some context. I will speed up more and more now and do equals monitor event. And we will say do an Avance enrichment, do a function called node lookup, selection function. Look here what we have. Look up node details. Before adding these attributes from discovery, if we look into discovery, here's the complete discovery within Helix platform. And if I search on one of the nodes, that's need to reload this one. So I go to the home page, probably timeout to discovery. Let's load it once more and do the search. Is some host. I just go into one of the hosts I'm using. As you can see, a discovered node has a lot of attributes, as you can see. So you can use them to easily enrich your event. Powerful. This is very powerful. And if you hover over one of these, you can actually see the attribute name at the end. So this is type. This is vendor and continue like that. So this is what we're going to use in our policy. Okay. OS type vendor, close it like this. I took it correctly. Okay, good. What do you want to do? Enrich the event with OS. So I take a slot, event slot called OS, and here's a nice thing. As you can see, what we did, the step before, it's now created as variables I can use in my event processing. I will do an OS and continue to enrich from the discovery data source. We are happy with this. Enrich. Okay, apply. Enable. 3 policies, suppress, dub detection, topology, enrichment. So I will go back to my all the events. If we look at the events here, sort on events, we did have about 16 incidents created based on this. I will close them quickly like this. So we are back to start. And go back to the Postman client. We were here. I will send it once more. The same set of events. And you see the results of these three event policies. First of all, the noise is dropped, is no longer there, is not saved, doesn't exist in the system. You can see also the dub detection is kicking in with the repeater. We automatically increase the repeater. You don't need to code that or do anything. We take care of that. And you can see nicely now we have 4 incidents. Okay. So that's the power of event policies. And it was very simple, 3 simple event policies I created to get this result. Now, let's take the next step and watch this, take these events, this event policies, and send it into AIOps and see what happens. I will move this away and let's enter with AIOps. Here it comes, AIOps, Helix AIOps, the next layer, the last pillars in the whole AIOps platform diagram. So we have context, we have services, we have AIOps enabled, right? So this is the event console. It's empty. I do have the same set of event policies that we created on the other Helix tenant, as you can see, to filter events, dub detect, and to do topology enrichment. Exactly the same. So what we're doing here now is sending in the events to Helix AIOps. Quickly moving to the other collection that is pointing to the AIOps tenant and sending 1, 2, 3, 4. Couple of times. Let me show you what is happening. So switch screen, there it is. So this is now happening. I did send in the events, right? The raw events as we ingested, and we go through a number of event policies, the suppression, the dub detection, and the topology enrichment. But we now let Helix AIOps see if it can use the topology and the service to create a situation, and within the situation identify a root cause. And we don't stop there. We will also that Helix GPT create a nice summary from all the events and actually also give us some recommendations. What should we do on this situation? Okay. So I'm waiting a little bit for the situation to be created. Let's see. So if we then go back to the AIOps console, here it is. So this is the overview from Helix AIOps. You can see there's now some service context based on the same events being ingested. there's a automated correlation or machine learning correlation happen based on the events we did send in. So if we look at the situation, what did happen here is that we did send in the same events with the noise, with the dub detected events and everything. They went through the event policies, but also we wanted AIOps to put them in a correlated situation, just have one incident instead of 4. So we basically went from 16 incidents to 4 incidents using some event policies, and now enable AIOps. We only have 1 incident left that actually tells us about the situation. So this is machine learning correlation. If we dig into this situation, you will see Helix GPT, how it's enabled. First of all, you can see on the top, based on all the events we send in, Helix GPT will actually generate new content and describe the situation. What happened? What is the root cause? What happened next? As you can see, this is actually based on all the event messages. Nice. And best action recommendations. So we generate new output, new content. And you can see, okay, this situation that happens with the events you sent in, I've created an incident. Here's the impacted service, but I will also help you to identify and remediate this. So start by high utilization is the root cause. Start by identify the process that are consuming the high CPU, analyze the process, optimize the process, monitor the system. You can see all the steps, right? It's quite amazing. And we don't stop there. If you look here on the code wizard, we use generative AI to generate code from the different steps. So if you take Bash here, you can see how to get the top processes and analyze the process that went wrong. And we do, of course, say, hey, this is generated by AI. You can have it as a template, but please test it. Ask Helix GPT with events. You can start to have a conversation, basically. What was the impact of this? And thinking, what is the impact? I'm working on it, and shows the results. Okay, back to the presentation, because I think time is running out.
Yeah, you are running out of time. It's exciting. There's a lot to cover.
So this is basically what we did. More meaningful events. We did send in raw events. We did create some event policies, filtering out the noise, dub detection. We did the enrichment with discovery data. Quite cool, powerful. We got some good events, and now we let them be the next enabler for machine learning situation, because isolation and best action recommendations. What did we learn? On the platform, microservices, containerized, cool, flexible, scalable. We did look at the event lifecycle and how it maps to incident as well, status. We went in and built some policies from scratch, and how our event management is contributing to AIOps.